Alrighty, for Chapter 6, there's really not a whole lot new in here, but it's more about trying to help you write programs and find the errors yourself. I'm mostly just going to point out some high points to all of this. So the return values, okay, we've seen that. We've seen a return in a function definition. That's, this is just showing these different returns, and they point out here's a definition that didn't work very well, but then using this definition, they point out something very important about the return. So this bad absolute value, it says it's not correct, okay, because if you put in 0, it doesn't pass either of those tests, so it doesn't know what to do with it. Well, in that case, it still returns something. It doesn't give you an error saying that you went through the program and really didn't do anything. Well, because that's not true. It checked this one, and then it checked this one, and neither of those was true, so it fell on through, and it had no return, but you were asking for it, right? Because if you put in 0 here, it will never give the return statement, but it will still return something, and that will be the word none. Okay, so that's, I think, important to realize, is that you may get an error on something like if you said, something like let A equal bad absolute value of X, and then you went to use A as a number and it didn't work and you got an error. Well, one of the things to check is well, what is A? What is it? The word none? And so this is just to point out that it is possible to think the only way this is going to work is if it returns either the negative X or X, but no, if it doesn't meet any of these, it still goes to the bottom of the program, and then since it has nothing to return, it just says none. And so there are functions, right, where you wouldn't necessarily return a value, and in those cases, if you check the return value, it would be none. Okay, so and we've done this, I think, exited a for loop with a return statement in that. And then see, in 6.2 they start getting into some strategies for writing bigger programs. And one of the things is I like their I don't think I've ever used this phrase, incremental development. Maybe I have, but the idea is to start simple. So you don't, if you're writing something bigger, you don't necessarily want to try to put the whole thing in and then just see if it works. You put in various pieces and make sure they're working, so that then when you put in the next piece and try it out and it doesn't work, oh, well, then you right away know that that is the problem piece. So for instance here, where they're finding the distance between 2 points, they first just define the function, use their colon there, and return 0, 0. So what are we doing? We're just trying to see, is this okay? If I did this, is it going to work? And so then later they call distance 1, 2, 4, 6, and it returns 0. It worked. Okay, it's not useful yet, but it worked. And so then they say, well, the next step is make sure I get the differences between the x's and the y's. And so they said dx is x2 minus x1, dy is x2 minus y1. And if you run that, you should still, if you run this same command here again, you should still get 0, 0. But the key is, even though it didn't look like anything changed, you just went through this and and Python didn't say it was wrong. Again, it's not much use yet, but it didn't say it was wrong. And then here they do a d squared and do the dx squared plus dy squared. Okay, so those differences squared, and they check that. Again, it ran. Great. And then the result, they do that square up there and take the square root of it, and then they say, oh, now let's change it to return result, and it worked. Okay, so it's just, you look at stuff like 6.2, think about it, and try that. Now here's one I use immensely. Okay, print, the print statement. So it's not unusual for me to have in maybe even just 20 lines of code of Python, I might have 4 or 5 print statements, because I just want to see what I have at that moment. And so you could do something like, let me get this here, so I'll copy that. Let's go to this untitled document. Okay, so there's my definition, and then I'm going to say, I'm just going to say, in this case, print, just to see it, print distance of 2 comma -1, so that's x1 y1, and then x2 y2, maybe 3 comma 4 or something like that, and I can run that, and there we get an answer. Now if I didn't like, if for some reason I thought I'm not too sure about that answer, what I might do is, you see, litter this thing with print statements. So print dx comma dy, and then after this statement, print d squared. Okay, now I probably wouldn't have it do a print after the result, because that is what I'm printing here. So you see, I would run this then, and the numbers are 1 and 5, and of course I know what I put in, and so I could say, okay, the difference between 2 and 3, yep, that's 1, and the difference between -1 and 4, that's 5. So yep, that worked. And then 1 squared plus 25 squared is 26. Yep, that worked, and I assume the square root worked then, and so forth. So, and then as I do this, I don't necessarily get rid of them right away, or maybe ever, because if I decide, okay, that's working fine, then I'll comment it out, and I'll comment that one out, and then it goes back to that. And I use that a lot when I'm trying to troubleshoot bigger programs. So yes, I'd say heed that advice. Now again, they mention the composition of functions, so calling one function by another function, and let's see, they're I don't know what the heck they're saying there. Find the area of the circle, wrap it. Okay, we call function area 2 to distinguish between area 1. yeah, they're just saying here. I thought they were trying to give some debugging advice, but they're just saying that area 2 could be even more compact than it is. So it calls this area function, and what you could do is, the result is returning area of radius, and so they could. I think they missed something here though. Wait, area, distance. No, that's right. Okay, so they made this into one single step because they came in here and then, well, the first thing they did was find distance. That's what they're doing inside here. They're finding the distance. Then once they got the distance up here, that gave them a radius, and they could call area on that radius, so then that's what they do. And then they assigned area to result and returned result. Well, you didn't have to do that. You could just return that, which is what they have there. So you can certainly clean up code sometimes that way. With me, it can vary. Sometimes this is a great idea. Other times it really hides things and makes it harder to debug and find those problems. Now here they just introduce Boolean functions all of a sudden, and they're just doing a test here. They say, okay, define this function is divisible. So what you want to know is x divisible by y, and that's really just a true or false, right? And so you can return Boolean values. So you can return true, you can return false. That's something nice at times. So like here, they say if is divisible equals true. Oh, right, so this should output either true or false. And if it equals true, then you do something. Except they're saying it might be tempting to write that. No, you don't need that part. So let's try just looking at is divisible. So I'll take that and go up here and get a new cell. I'll put that in. Whoops. I don't know what just happened. That was weird. Okay, so here's the test for is divisible, and we'll come down here and we say if is divisible, how about 6, 5? So there's my true or false right there. And so if is divisible, then I could do something like print if it is divisible, I might want to print out true, or I might want to print out something like divisible. And then else, and we could print not divisible. Whoops, I don't know what I did. Oh, I hit my I hit okay, so oh, I didn't put those in quotes. See, that would have been a problem. But put that into double or single quotes, and same thing here. See here, notice it says not. You can't use that. Well, I can if it's in quotes, because then it's just a string. Okay, so here you see that gives true or false, so that should be all I need. So let's try running that. Oh, and it didn't like something. Oh, did I spell it wrong? Yes, is divisible. So let me know right away. I hadn't defined that function. So not divisible. All right, so it works just fine that way because it returns a true or false. And so if true, then say this, else, do this. Okay. So that's a little bit with that. Now, this is a nice thing to heed here. Programming style just suggests things like, 4 spaces, not a tab to indent. Keep lines short at like 78 characters. This is all for being able to read it later. And now they say, and this is not something I tend to do, I do actually kind of a combo of this. If they mention camel case here, what I would tend to do with a lot of function, we'll go with functions, we don't know what classes are yet. I would tend to say if its name was camel case, I would use a lowercase c here and then the uppercase C here, but not use the underscores. Perhaps if I was writing for somebody else I would, but I'm not. So I'm typically writing for me, and so underscores for me much slower and so forth than just capitalizing that next word. Put any imports we do at the top. Keep the function definitions together. Yeah, you put all your definitions at the beginning and document what things are. And they mention using 2 blank lines between function definitions and so forth for better reading. But these are just good things to heed, and so that's something you want to think about. Now I'm just going to gloss over the unit testing. I don't think we're there, and see that's the end. So that's really all that's in Chapter 6. It's more of a self-help for you, and so that's about all I'm going to say about it.